Hi, I'm Victor, the main organizer of the Full Stack Flutter conference. On this channel we publish the best talks from the conference every week throughout the year, so make sure to subscribe so you don't miss out. I'm also the founder of ServerPod, so if you want to build your backend in Dart, make sure to check that out too. Oleksandr Leushchenko is a GDE in Flutter and Dart, an experienced public speaker, lecturer, AR enthusiast, OSS contributor, mentor and mobile developer. In his talk, he will discuss what to do when your backend isn't ready. Let's go!
It is hard to find a modern mobile application without any backend. Sometimes backend presence is very obvious. For example, mobile apps usually rely on a backend for the following tasks. Manage users when you sign up for a mobile app or log in with existing credentials. The backend verifies your information and grants access. It handles tasks like password validation, account creation, and user session management. Remote data storage. This could include user-generated content such as photos, videos, or documents, as well as data like user profiles and preferences. For example, a social media app stores users' posts, comments, and media files on the backend server, allowing many users to access their content from any device. API integration. Mobile apps frequently integrate with external services and APIs to access additional functionality or data. For example, a travel app might integrate with a flight booking API to allow users to search for and book flights directly within the app. Sometimes backend presence is less obvious. Even when the application doesn't seem to have a functionality that relies on the backend, it still probably has remote configuration or feature toggles. They allow developers to control certain aspects of the app or make experiments with user experience without requiring users to download updates. Payment processing and transaction handling. Not having a backend that facilitates transactions opens doors for many potential frauds. When a user makes a purchase or initiates a financial transaction within the app, the backend processes the payment, validates it, and updates the relevant records. Analytics and crash reporting. Mobile apps often collect anonymous usage data to improve the user experience. The backend gathers this data from various users, analyzes it for trends, and provides insights to the app developers. No matter what kind of mobile application you are working on, you probably need a backend. In a perfect world, when you start working on an app, the design is ready and the backend, if not already developed, then at least is being implemented in parallel with the app. In practice, that's not always the case. There might be unexpected delays on the backend side caused by various reasons, like unexpected technical challenges or resource constraints within the development team. Additionally, dependencies on third-party services or APIs may introduce complexities that extend the timeline. Moreover, coordination issues between different teams or stakeholders could also contribute to delays in backend implementation. What can mobile developers do if they need to display some data on the screen when the backend is not ready to provide that data? The first and easy solution is to hardcode the missing data right in the UI. However, this approach can lead to many problems, including extensive refactoring and potential issues with data consistency. Let me show you a few more reliable alternatives. I'll be presenting them in the order of my personal preferences, however, feel free to pick the one you are more comfortable with. By the way, hardcoding data right in UI is not wrong either. You may choose this option if you know that the hardcode will be needed for a limited amount of time and it's an exceptional case. However, if you regularly hardcode data, consider using one of the more robust options. Now let me introduce myself. My name is Oleksandr Leushchenko. I'm a Google developer expert in Dart and Flutter from Ukraine, and a senior staff engineer at Tide. I've been working on mobile applications for more than a decade now, and I'm happy to share my experience with you today. Before we dive into different options on how to keep mobile applications on track when the backend is not ready, I'll give you one piece of advice. Always define the contract first. In a perfect world, together with the backend team. No need to write the actual implementation now, but at least you'll be sure that at some point the backend delivers what the app expects. You might want to use Swagger or a similar tool to define a contract between mobile apps and the backend, and even generate some code after this contract specification. However, if you're not a fan of the complexity of this solution, there is a simpler way. The bare minimum you might want to have is just a Google Doc document, or a Confluence page, or a Notion page, or just a text in any editor, including a real whiteboard hanging on the wall. You need a list of endpoints, sample requests, and sample responses. Let's get our hands dirty. For today's talk, I decided to pick an open-source Flutter project from Anna Leushchenko. Here is the application running. You may see that it fetches the list of space launches. Unfortunately, we will not have much time to dive into the implementation of the project. But the good news is that the implementation was covered in detail during one of the Observable Flutter series, so go check it out later. Let's pretend that the backend for this project does not exist. A proper contract document should have a list of all endpoints and sample requests and sample response models. Let's build such a document now in Google Doc. Here I have the source code of the project on the left and an empty document on the right. Endpoints are described in the api.dart file. For the sake of simplicity, let's cover the two first APIs only, so let me copy two headers in the document. We don't have request models for these endpoints, so I'll create tables with responses. For the articles endpoint, the response contains an article model. The article model is clearly already defined, so I could generate some sample data. As we are limited in time, let me just copy-paste some sample data I already have. For this endpoint, for status code 200, the output will be this list. And for the endpoint for article details, for status code 200, the output will be just a single article. And that's it. You might wonder why we even bothered with this document, but believe me, that document will be used as a source of truth when, not if, when the contract is implemented incorrectly, no matter whether the implementation is wrong on the mobile or backend side. As you may see, it doesn't have to be complex. I'd rather even recommend you to keep it simple if you can. The API contract is defined, and now we may start working on the mobile app. To keep the mobile app development on track when your backend is not ready, you may create another backend. Let's build some stub server that will always return predefined data. Don't be afraid, you would not need to write it yourself. The open source community already covered you here and provided a wide variety of tools, like, for example, a JSON server. I'll copy-paste some data from the contract document into a local file. Let's create a backend.json file with the following content. Now I need to install the JSON server. I can do that with the following command: npm install with flag g JSON server at 0.17 port 3. It is important to install 0.17.3 version, as in the latest versions there was an optimization with IDs, and now it will not work for this particular API. It's time to run the server. npx json server backend.json. It says that the backend is up and running at localhost port 3000. To make the app use this endpoint, I need to change the di app module. I'll leverage the dev environment and point it to the new endpoint. Now I need to run code generation. More on that in the observable Flutter series I mentioned earlier. Now I need to make the app use this new environment. Let's create another entry point that developers will use for development. We may run the app now. Look, it works and it shows the stubbed data. Clearly, having a stubbed backend on a MacBook is not a perfect solution. Moreover, stubbed backend is still a backend. If you want to make it available for the entire team, you'll need to deploy and maintain it. However, it gives you a lot of flexibility. It doesn't even have to be a stub. You may create a BFF, backend for frontend, layer that will be in the middle between your apps and the actual backend. When the actual backend is not ready, you may return stub responses. And when the real implementation is there, you may redirect the BFF to the actual backend. To me, the biggest disadvantage of this solution is the maintenance cost. At some point, you may find yourself writing another backend. Not ideal. Is there an easier way? If you are doing testing in your project, which you should, there are no excuses not to do that, you are familiar with the concept of fake. A fake is a simulated object or component that mimics the behavior of a real system or component. Fakes are often used in testing when the real class or component is either unavailable, not yet implemented, or difficult to set up for testing purposes. However, you may use fake in an actual implementation too. Let me show you how this can be done. First, let's prepare data for the fake API implementation. I'll create a new file, fake data, with the responses from the contract document. In Dart, you may implement any class. Hence, let's create a new fake API file and implement Spaceflight News API class in it. In the getArticles method implementation, I'll decode a sample data and manually convert it to the list of articles. For the getArticle, I'll call the getArticles method and just filter the result. In order not to compromise the security of the application, I highly recommend you to make sure this mocked API implementation and all its data is not included in the production build. You may rely on the tree shaking mechanism for that. We already have an entry point that's supposed to be used in dev environment only. This project uses injectable that generates a DI initializer for the whole package, and if I register the fake API implementation there, it will leak into production. To work around this issue, let me do an awkward trick. I'll unregister the actual API factory and register the fake implementation instead. The fake API is mentioned in the main dev entry point only. Hence, when you build the application for production, your fake API class and all its data will not be included in the bundle. If you are interested in how to do this properly, tag me on Twitter so that I know that people are curious about that topic, and probably that would be my next talk or video on YouTube. Let's run the app. Ta-da! We have the app that believes that the API exists, but in fact never tries to communicate with that API. What I like in this solution is its simplicity. What I don't like is the fact that we dropped a piece of the implementation from the app and replaced it with another implementation. Ideally, I'd prefer to keep as much of the production code as I can. How can we do that? With interceptors. Let's refactor the implementation. In this project, the communication is handled with DO. This package has interceptors built in. If the communication is implemented via HTTP in your project, use HTTP interceptor package. The idea is absolutely the same. Let's create a new class, Spaceflight News API Interceptor, that extends interceptor. This interceptor needs to know the base URL for requests it needs to intercept. I will override the onRequest method that is called when a network request is about to be sent. If the base URL of the request is not the one we expect, we will not handle it. The interceptor will check the path. If it is articles, we resolve the request with the fake API data. If it is articles with an ID, we again resolve the request with some sample article. All other requests will be rejected by the interceptor. Just like with the mocked backend from the previous option, you don't want this class to be included in the production app bundle. So I'll use the same trick with different entry points for the production and development, and add the interceptor in main dev.dart file. If you decide not to mock DO instance in your tests and follow the social testing paradigm, you may use this interceptor and benefit from testing more functionality with less code. But that's a completely separate topic. By the way, if you're interested in this topic, again, tag me on Twitter. Let's verify that the app works. Neat. To recap, if the backend is not ready, you may implement a stub for the backend, which might be as simple as a JSON server or a proper BFF with more custom logic. If you go this route, remember that the stubbed backend is still a backend, and it requires maintenance. However, you'll get as much flexibility as possible. Plus, you'll be 100% sure that the mobile application has no knowledge about the fact that the backend is not real. The other way is to make the app process networking without making any calls, either through a fake implementation or via intercepting network requests before the app actually makes them. I prefer interceptors as they allow to share the serialization and deserialization logic between the production and development implementations. As a bonus, this approach may simplify testing. It requires little to none maintenance, however, when used carelessly, can lead to potential security issues because of the hard-coded data in the app bundle. I hope that was useful. Happy to answer all your questions now.